So in this video, we are going to solve flow rate and velocity math problems. And these are for the water wastewater operator license exams. So the first problem that we're going to solve states that find the flow in CFS in a 6-inch line if the velocity is 2 feet per second. So it's very important that you write down the information that is given using a sketch. So here the flow is in that needs to be found is it needs to be in CFS. So we're going to find the flow in CFS, which is cubic feet per second. This is what we're going to find out. And the value that is given, or what is given, is that it's a 6-inch line. That means the diameter of this line is 6 inches and the velocity is 2 feet per second. So we know that flow Q is equal to the surface area of the flow multiplied by the velocity. So in this particular problem, it is assumed that the pipe is flowing full. Therefore, the surface area of the flow, which is this area that is being hashed, and this is the same as the surface area of the pipe. So this flow, which needs to be calculated in cubic feet per second, is going to equal to 0.785 d squared, and this needs to be in square feet multiplied by the velocity in feet per second. So the feet squared times feet is going to give you the cubic feet, and the seconds is in the denominator. So when we plug in these values, you get 0.785 times. Now we need the area to be calculated in feet square, but the diameter is given in inches. So we need to convert the diameter from inch into feet. So 6 inches, and the conversion that you're going to use is 12 inches to a foot. And the d is squared, the diameter is squared. So basically the inches cancel out and you get 6 feet square, and the velocity which is given, which is 2 feet per second, and this value works out to 0.4 cubic feet per second. That's the answer. The second problem states a rectangular channel 3 feet wide contains water 2 feet deep flowing at a velocity of 1.5 fps. What is the flow rate in CFS? So the channel is 3 feet wide. So this is the channel width is 3 feet. The height of the water, which is how deep the water is flowing, is 2 feet. And the velocity is equal to 1.5 fps, which is feet per second. And what it's asking is what is the flow rate, which is Q in CFS, or cubic feet per second. This is what we need to find out. So again, flow Q is equal to the surface area of flowing water times the velocity. And again, the flow is to be calculated in cubic feet per second, and the surface area of the flow in the channel is going to be the height times width. Again, this needs to be in square feet multiplied by the velocity, which is going to be in feet per second. So plugging in the values, you get 2 times 3 square, because both of these are in feet. 2 feet times 3 feet, therefore feet square, per second, and that comes to 9 cubic feet per second, which is the answer. The third problem states if a chemical is added in a pipe where water is flowing at a velocity of 3.1 feet per second, how many minutes would it take for the chemical to reach a point 7 miles away? So basically, they are giving a velocity of 3.1 feet per second. The distance that needs to be traveled is equal to 7 miles. And what needs to be found out is the time in minutes to travel this distance given this velocity. So the time in minutes can be calculated by dividing the distance traveled by the velocity. And the reason is that velocity is distance per time. Therefore, basically, the distances will cancel out, and what you will get is the unit of time. So in this particular case, you have the distance traveled is 7 miles, and then this 7 miles needs to be converted into feet because the velocity is in feet. Therefore, 7 miles times 5280 feet per mile. And basically, this is the conversion that is coming from the formula sheet. And so just this will give you the total feet, and then you're dividing it by the velocity, which is 3.1 feet per second. And the thing is that the time needs to be calculated in minutes, and we have this in seconds, so we need to convert the seconds into minutes. So we know 60 seconds per minute. So with this, the seconds will cancel off, the feet cancels off, and basically what you get is the answer of 199 minutes. Another alternative way to solve this particular problem is that we know that the velocity of the water is 3.1 feet in 1 second, which is 1 divided by 60 minutes. So for 7 miles, which is 7 times 5,280 feet, how many or x minutes? So in order to calculate x, what you have is this multiplied by this divided by this. So 7 times 5,280 multiplied by 1 over 60 divided by 3.1, and this will work out to, again, 199 minutes.